Good morning, dear students. In the previous class, we were discussing about path length and displacement. Now, we shall discuss about scalar and vector quantities. Now, let us see what is scalar quantity and what is vector quantity. Scalar quantity means quantity with magnitude alone and no direction. Now, what is magnitude? Magnitude is nothing but numerical value that defines the measure of a quantity. So, it represents the numerical value. Now, let us see an example. For example, you have a boy standing here. So, let us take this point as A. So, the boy starts moving from the point A and reaches the point B. Now, I'll say that the distance covered by the boy is 10 meter. What is this 10? 10 meter is the numerical value which tells me the measure of the quantity. So, this gives the magnitude. That means magnitude is nothing but numerical value that defines the measure of a quantity. If I say that the boy covers the distance of 10 meters, that's all. I am not bothered about the direction, whether he went in north, south, east or west. When we are dealing only with the magnitude, we call that quantity as a scalar quantity. So, it deals only with the numerical value. So, for example, time. So, for example, now it's 10 o'clock means just it tells the numerical value. So, we are not bothering about the direction. Speed, mass, etc. are scalar quantities. They have only numerical value but no direction. So, we'll move to the next quantity, that is vector quantity. So, now when I talk about vector quantity, we not only need magnitude but also need direction. Example of vector quantities are displacement, velocity, weight, acceleration, etc. So, in this case, if I am talking about displacement, then I should always mention it in this way, that this boy moved 10 meters towards east. Towards east. So, that is called displacement. So, whenever it is displacement, I always need to mention both magnitude and direction. So, what do you mean by vector quantity? Quantity with both magnitude and direction. So, examples are displacement, velocity, acceleration, weight, etc. are vector quantities. So, okay, we'll move to the next topic, that is speed and velocity. So, already you have learned these two topics in 8th standard. So, what do you mean by speed? Speed is nothing but rate at which an object covers the distance. So the path length the object covered, so in a unit time is called speed, the rate at which an object covers the required distance. It is a scalar quantity, means it gives only numerical value, no direction. So, what is the formula to calculate the speed? So, the formula is path length or distance covered divided by time taken. So, gives the speed. So, next SI unit of speed is meter per second. So, the path length or distance travelled will be measured in meter divided by time taken will be measured in seconds. So, the unit SI unit of speed will be meter per second. Now, we will move to the next quantity, that is velocity. What is velocity? Rate at which an object changes its position. So, here it is nothing but speed with the direction. So, it is also will take path length covered in a unit time. So, in a particular direction. will be considered as velocity. So, since it consider direction is a concern, so here it is called vector quantity. So, it's having both numerical value as well as direction. Since it's having both the direction and magnitude, it is a vector quantity. So, what is the formula to calculate velocity? So, here, we take displacement. So, that means displacement means, so the distance between the initial and the final position. So, that we consider divided by time. So, displacement divided by time gives velocity. So, the SI unit of velocity is also meter per second, because displacement is nothing but distance between the initial and final velocity. So, that distance will be measured in meter and divided by time will be measured in second. So, the SI unit of velocity is meter per second. Let us see an example to understand the speed and velocity clearly. Let us take the same example of the small boy who is at rest at his home. Let the distance between the house and the McDonald's is 2 kilometers. So, let us take this position as McDonald. So, this is his house. So, here the distance between his house and McDonald is 2 kilometers. Now, this boy starts cycling. He starts from his home and reaches McDonald again. Again, he takes U-turn and comes back to his house. Then, what would be the speed in this case? You know that speed equals distance by time. Distance by time. So, here, what is the total distance travelled? So, here this is 2 kilometers. From his house to McDonald, 2 kilometers. He is taking U-turn and again returns to his house. So this way 2 kilometers and again 2 kilometers. So, totally 4 kilometers is the distance travelled by him. So, now, what is the time taken by the boy? Let us suppose he took 1 hour to go to McDonald, and so it takes 1 hour to go to McDonald and again 1 hour to return to his house. So, totally what is the total time taken by him? 2 hours. So, here 4 kilometers is the total distance travelled by him, and 2 hours is the total time taken by him. So, 2 ones are 2 twos are, that is 2 kilometers per hour. 2 kilometers per hour is the speed of the boy. So, now we will see how to calculate velocity. So, here we take 2 cases. In the first case, suppose the boy starts from his house and reaches McDonald. So, what will be the velocity of that boy? So, here the initial position is his house and final position is McDonald. So, the displacement is nothing but the distance between the initial and the final position, that is 2 kilometers. And what is the total time taken by the boy to reach the McDonald? That is 1 hour. So, what will be the velocity then? 2 kilometers per hour. In the second case, if the boy starts from his house and reaches McDonald and it takes U-turn and again returns to his house, in that case, what will be the velocity? So, you know that, so starting point is his house. So, final position also the same point. Here, if the initial and final positions are same, then what will be the displacement? It is 0. So, the distance travelled displacement will be 0. 0 by time is 2 hours, that is you will get 0 only. So, 0 kilometer per hour. So, will be the velocity. So, velocity is nothing but displacement divided by time. Now, let us move to the next topic, that is uniform motion and non-uniform motion. Uniform motion is nothing but a body is said to be in uniform motion if it covers equal distances in equal intervals of time. Non-uniform motion means a body is said to be in non-uniform motion if it covers unequal distances in equal intervals of time. Dear students, I am sending a video's link which is related to this topic. Do watch that video which helps you to understand the topic clearly. So, okay, we shall continue in the next class. Take care. Bye.